Welcome to this video tutorial on the graphs of cotangent, secant, and cosecant. We are going to look at one of each of those types of graphs where we are given a transformed graph and we want to determine its equation. For this first one, we are going to go in terms of y equals the cotangent of x. So the first thing we might want to consider is what the basic shape of cotangent looks like. And the basic shape of cotangent is pictured on your screen. So we are going to analyze our graph as we have done over the duration of the course. First thing that we can look at, perhaps, is this vertical change between the top and bottom points that we have bolded. From 3 to -7 is a change of 10. In the original graph, from a +1 to a -1 is a change of 2. So right off the bat, we know we have a vertical stretch of 5 in play because 2 times 5 gives us the 10. From a horizontal standpoint, in our new graph, it's a horizontal change of 2. In the original graph, it was a horizontal change of pi. So we want to think about what do we have to multiply the original pi by in order to get 2, and the answer is 2 over pi. As a result, we have a horizontal stretch of 2 over pi. Be mindful that when we incorporate that horizontal stretch into our equation for the graph, that we have to take its reciprocal. So we've taken care of vertical stretch, horizontal stretch. There are no reflections happening in this graph. As for the other items, left, right, up, down, let's look at x equals 0, which scoots over to x equals -3. Since x equals 0 is not impacted by any stretch, we know that this graph moves to the left 3. And as far as up-down goes, a lot of times it's nice to look at something that has a coordinate of 0. So this middle point at pi over 2 comma 0, we need to know what the corresponding y value is over on this graph. And we can find that, first of all, we know its x-coordinate is going to be -2. But we can find that by taking the average of 3 and -7. So that's going to be -2 as well. 3 plus -7 is -4. -4 cut in half is a -2. Then from 3 to -2 is 5, our vertical stretch. And from -2 to -7 is also 5. So what we see by looking at that point in magenta is that this graph was moved down 2. So this was in terms of cotangent. We're going to have y is equal to 5 times the cotangent of pi over 2. Make sure you take the reciprocal of the horizontal stretch. Put the parentheses around our x plus 3, and then we have -2 at the very end. That would be the formula for our particular graph. Let's scroll into another example, and we're going to look at the example on the screen right now. This example is going to be one that we do in terms of y equals secant of x. So let's start with its basic shape so that we have that in mind. There's the basic shape of secant. And let's also finish off this graph in the sense that we need to specify some other points. So from 3 to 5 is 2. When we cut that 2 into 2 equal pieces for right here and right here, it's going to tell us that we have ourselves x equals 4 as this vertical asymptote. And it's also going to tell us x equals 6 as this vertical asymptote, as well as this point has an x-coordinate of 7. We also know this point is going to have a y-coordinate of -4 just to keep everything on pace. So now when we go to write things out, we need to look at, first of all, the fact that this was reflected across the x-axis. Secondly, this span right here is typically 2 on the original graph. On this new graph, it's 10. So we have a vertical stretch. And just like our earlier problem, the vertical stretch is going to be 5. Horizontally speaking, to span this entire graph right here goes 4. Horizontally speaking, to span this entire graph here goes 2 pi. So what did we have to multiply 2 pi by in order to get 4? And the answer is 2 over pi. So we have a horizontal stretch of 2 over pi happening. Now when we go to determine left, right, up, down, For going left, right, it's nice to look at some place that has an x of 0 right here. That x of 0 will not be impacted by any horizontal or vertical stretches or any reflections. So it will match up with this other point that I've highlighted in green, which tells us that this graph moved to the right 3. Now as far as up and down goes, possibly the easiest way to take care of up and down is to look at what we might call like the midline. Where is that line that would be in the middle of our graph? Well, in this case, it's at y equals 0. But on our modified graph, it's going to be the average of the y coordinates of our special points. So 6 and negative 4, their average would be negative 1. Or no, our average would be positive 1. 2 divided by 2 is a positive 1. So that's telling us that the graph moved up 1 at the very end. Therefore, its equation would be y is equal to negative 5 times the secant of pi over 2, make sure to take the reciprocal of the horizontal stretch, quantity x minus 3 plus 1. That would be the formula for this graph. And we have one more example that we're going to look at, and this last example is one that we are going to do in terms of the cosecant. So this will be y equals cosecant of x. Let's look at its basic shape. Its basic shape is pictured. And again, it looks like we need to commence by figuring out missing items on this picture that we have. Now, one thing that we see here is 4 pi and 20 pi. It changes 16 pi between these two increments, which means each of them is going to be 8 pi in length, which is telling us that this will be at x equals 12 pi. And then this will continue backwards, and we'll get x equals negative 4 pi. And this will continue forwards, and we get x equals 28 pi. If we also wanted to, right at the moment, put in our midline, if we want to think about it that way, the middle line here is going to be the average of 10 and 1, which is going to be y equals 11 halves. Vertically speaking, in the original graph, it's 2, the change. In this graph, from 10 to 1, it's going to be 9. So in this case, we have a vertical stretch happening, and the vertical stretch is going to be 9 halves. We also have a reflect across the x-axis as it went up to down. Horizontally, we have an entire span of 32 pi in our new graph. In the original graph, it just goes 2 pi. So what did we have to multiply 2 pi by to get 32 pi? Well, the answer would be 16. So we have a horizontal stretch of 16. Left, right. Find somewhere where x is 0, figure out where it goes. So in this case, we're going to be scooting to the left 4 pi. And remember that on our original graph, the middle line, the line in the center, was at y equals 0. Again, anytime you've got a coordinate of 0, that makes it nice to figure out the left, right, up, down, because 0 is not impacted by vertical stretches, horizontal stretches, or reflections. So we know that this graph is going to go up 11 halves. Therefore, its equation is going to be y is equal to a negative 9 halves times the cosecant, take the reciprocal, 1/16 x plus 4 pi plus 11 halves. So really these graphs are not bad if two things happen. First of all, you have to know the basic shape. What does the original graph, its parent function, its basic shape look like? And then secondly, go piece by piece. Don't get overwhelmed. Look at the vertical change, find out what the vertical stretch is. Look at the horizontal change, find out what the horizontal stretch is. Be mindful if there's any reflections. And then look at somewhere based on a 0 to find left, right, up, down. Now, do you have to look at somewhere based on the 0? No, not necessarily.